Moving on to Chapter 9, which centers on relational database design by ER to EER to relational mapping. So Section 9 deals with ER to relational mapping algorithm, and Section 9.2 centers on mapping EER model constructs to relations. So the goals during mapping is to preserve all information that includes all attributes, maintain the constraints to the extent possible. Relational model cannot preserve all constraints. For example, max cardinality ratios such as 1 to 10 in ER, exhaustive classification into subtypes, etc. Students are specialized into domestic and foreign. Minimize null values. The mapping procedures described has been implemented in many commercial tools, and there are tools that do this stuff for you. You basically draw a diagram and they produce essentially the schema for you. The ER to relational mapping algorithm, and this is the first of 14. Step 1 is mapping of regular entity types. For each regular strong entity type E in the ER schema, create a relation R that includes all the simple attributes of E. Choose one of the key attributes of E as the primary key for R. If the chosen key of E is composite, the set of simple attributes that form it will together form the primary key of R. An example, we create the relations employee, department, and project in the relational schema corresponding to the regular entities in the ER diagram. SSN, DNUM, and PNUM are the primary keys for the relations employee, department, and project as shown. Figure 9.1 shows this relationship. Step 2, mapping of weak entity types. For each weak entity type W in the ER schema with owner entity type of E, create a relation R and include all simple attributes or simple components of composite attributes of W as attributes of R. Also include as foreign keys attributes of R the primary key attributes of the relation that correspond to the owner entity types. The primary key of R is the combination of the primary keys of the owner and the partial key of the weak entity type W, if any. An example, create the relation dependent in this step to correspond to the weak entity type dependent. Include the primary key SSN of the employee relation as the foreign key attribute of dependent, renamed as ESSN. The primary key of the dependent relation in the combination ESSN dependent name because dependent name is the partial key of dependent. Step 3, mapping of binary one-to-one relation types. For each binary one-to-one relation type R in the ER schema, identify the relations S and T that correspond to the entity types participating in R. There are 3 possible approaches. One is foreign key, where 2 relations approach. Choose one of the relations, say S, and include a foreign key in the S, the primary key of T. It is better to choose an entity type with total participation in R in the role of S. An example is a one-to-one relation of manages is mapped by choosing the participating entity type department to serve in the role of S because it participates in the manages relationship type in total. The second step is to merge relation, that is, or the second alternative is to the merge relation, that is one relation option. An alternative mapping of a one-to-one relation type is possible by merging the 2 entity types and the relationship into a single relation. This may be appropriate when both participations are total. Cross-referencing is the third type, or relationship relation. This is 3 relations option. The third alternative is to set up a third relation R for the purpose of cross-referencing the primary keys of the 2 relations S and T representing the entity type. Step 4, mapping of binary 1-to-n relationship types. For each regular binary 1-to-n relationship type R, identify the relation S that represents the participating entity type at the inside of the relation type. Include as many as foreign keys in S, the primary key of the relation T that represents the other entity type participating in R. Include any simple attributes of the 1-to-n relation type as attributes of S. An example is a 1-to-n relationship over works for controls and supervision in the figure. For works for, we include the primary key D number of the department relation as a foreign key in the employee relation and call it DNO. An alternative approach is to use a relationship relation, a cross-referencing relation. This is rarely done, however. Step 5 involves mapping of binary M to N relation types. For each regular binary M of N relation type R, create a new relation S that represents R. This is a relationship relation. Include as foreign keys as foreign key attributes in S the primary keys of the relation that represent the participating entity type. This combination will form the primary key of S. Also include any simple attributes of the M to N relationship type or simple components of composite attributes as attributes of S. An example of an M to N relationship type is the works on from the ER diagram is mapped by creating a relation works on in the relational database schema. The primary keys of the project and employee relations are included as foreign keys in works on and renamed P&O and ESSN respectively. Attribute hours in works on represents the hours attribute of the relation type. The primary key of works on relation is the combination of the foreign key attributes. Step 6 is around mapping of multi-valued attributes. For each multi-valued attribute A, create a new relation R. This relation R will include an attribute corresponding to A plus the primary key attribute K as a foreign key in R of the relation that represents entity type of relationship type that has A as an attribute. The primary key of R is the combination of A and K. If the multi-valued attribute is composite, we include its simple components. An example is the relation depart locations is created. The attribute D location represents the multi-valued attribute locations of departments, while D number as foreign key represents the primary key of the department relations. The primary key of R is the combination of D number and D location. Step 7 is the mapping of n-ary relation types. For each n-ary relationship of type R, where n is greater than 2, create a new relationship type S to represent R. Include as foreign key attributes in S the primary keys of the relations that represent the participating entity types. Also include any simple attributes of the n-ary relationship type or simple components of composite attributes as attributes of S. An example is the relationship type supply SUPI in the ER on the next slide. This can be mapped to the relation supply shown in the relational schema whose primary key is the combination of the three foreign keys S name, part num, and project num. A summary of the mapping constructs and constraints from the ER model to the relational model: entity type, entity relation, one-to-one or one-to-n relationship type is a foreign key or relationship. M to N is a relationship relation and two foreign keys. M to n-ary relationship type is a relationship relation with n foreign keys. Simple attributes is an attribute. Composite attribute becomes a set of component attributes, and multi-valued attributes become relation and foreign keys. And value set becomes domain, and key attributes become primary or secondary keys.